Okay, we found out, or we learned that the way we handle nominal shear strength of reinforced concrete beams in ACI is that we have a steel component and a concrete component. And in this video, I'm going to cover the steel component of the shear strength of a reinforced concrete beam, Vs. What we're going to say, so a typical stirrup would look something like this. Okay? So that'll be in your beam. There's your flexure steel. And so this stirrup, if you take that cross section, has a vertical area of 2 bar areas. We're going to call that, so we don't get confused, the area of a bar is AS. We're going to call, let me draw that somewhere else. So the area of 1 bar is AS. This we're going to call AV. And in this case, AV is 2AS. It's the vertical area of the steel. And if it's inclined, you're going to have to take sines and cosines and something like that. In the US, we typically use vertical stirrups. Okay, each stirrup has a strength if it yields, okay, per stirrup. The strength is AVFY if it's yielded, and we're going to assume it's yielded. And the total shear strength across a section where you've cracked the beam at 45 degrees will be N times the strength per stirrup, which is AVFY. And the next question is, how many stirrups cross a 45-degree crack? Because we talked about principal tensile diagonal tension is at 45 degrees. So there you go. And you're going to have some stirrups that go across this crack. And the question is, how many of them go across the crack? And I've drawn that picture here. If this height here is D, because it's 45 degrees, that horizontal distance will be D. And if you space them at S, plus or minus 1 stirrup, the number that crossed that crack is D divided by S. So that's how many there are. So the total shear strength is the number of stirrups, D divided by S, times the strength of each stirrup, the area times Fy. And thus we get steel strength, shear strength due to steel for a reinforced concrete beam like this. And the 2 things you typically can change is the area, or the area of the stirrup, or the spacing of the stirrup. And you can change Vs, the shear strength due to steel in a reinforced concrete beam. The next thing we're going to talk about in the next video is the shear strength due to concrete.